Welcome to our channel. In today's video, we will explore the fascinating topic of coastal erosion and the threats it poses to our shorelines. Coastal erosion is a natural process where coastal land is gradually worn away by the relentless forces of waves, tides, and currents. However, in recent times, human activities and climate change have accelerated erosion rates, making it a growing concern. Let's dive into the causes of coastal erosion. 1. Wave action. Powerful waves generated by wind and storms exert pressure on coastlines, gradually eroding the land. 2. Sea level rise. As sea levels rise due to global warming, the shoreline is pushed inland, leading to increased erosion. 3. Sediment depletion. Human activities such as dredging, damming rivers, and sand mining disrupt the natural sediment supply, contributing to erosion. 4. Coastal development. Improper coastal development, including construction too close to the shoreline, disrupts natural sediment transport and exacerbates erosion. The impacts of coastal erosion are far-reaching and affect various aspects. 1. Threat to coastal communities. Erosion puts homes, infrastructure, and livelihoods at risk, especially in low-lying coastal areas. 2. Loss of beaches. Erosion diminishes sandy beaches, impacting tourism, recreation, and the natural beauty of coastal areas. 3. Habitat degradation. Eroding coastlines endanger vital habitats like dunes, marshes, and coral reefs, affecting biodiversity and ecosystem health. 4. Cultural and historical losses. Erosion can erode archaeological sites, historical landmarks, and cultural heritage tied to coastal regions. Managing coastal erosion is essential for preserving our coastlines. Here are some strategies. 1. Soft engineering approaches include beach nourishment, where sand is added to eroded beaches, and dune restoration to absorb wave energy. 2. Hard engineering structures. Seawalls, groins, and breakwaters are built to provide direct protection against waves, but they can have environmental and aesthetic implications. 3. Coastal zoning and planning. Careful land use planning helps ensure responsible development away from vulnerable coastal areas. 4. Climate change adaptation. Implementing strategies to mitigate and adapt to climate change, such as carbon emission reductions and sustainable coastal management practices. Let's explore some real-life examples of coastal erosion and the efforts to combat it. The Dutch coastline, including all estuaries, has a length of about 1,000 kilometers. The coastal zone can be divided into 3 regions with different characteristics. The southwest region with a large number of previous tidal inlets and islands. The central connected coast. The northern region with the Wadden Sea coast and its islands. The central connected coast is about 350 kilometers long, of which 75% consists of dune areas of varying widths, ranging from less than 100 meters up to a width of several kilometers. Coastal erosion was estimated to occur over 134 kilometers, spread along half of the Dutch coast. Large sections of the Dutch coast have been eroding for centuries, at some locations resulting in a retreat of 5 kilometers in 4 centuries. In the past, only an ad hoc policy against coastal erosion was followed. Measures were only taken when the safety of polderland was at stake or when special values in the dune area, e.g. drinking water areas, nature reserves, camping places, were threatened. Discussion on a new policy for the coastal defense of dune coasts started in the 1980s. In 1990, Parliament decided to adopt a new policy called Dynamic Preservation of the Coastline, in order to stop the further retreat of the coast, meaning that the entire coastline will be maintained at its 1990 position. Further erosion will be counteracted by sand nourishments. Sand nourishment has been a common measure to combat coastal erosion in the Netherlands since the end of the 1970s. When a nourishment project is carried out, sand excavated from the bottom of the North Sea, outside the -20 meters depth contour, is added to the near-shore zone. Initially, sand nourishments involved 6 mm3 of sand per year. Following ongoing research and especially taking into account the sustainability of the deeper shore, it was concluded that a higher amount is needed. From 2001 onwards, the Netherlands has raised the total nourishment volume in its coastal system from an average of 6 to an average of 12 mm3 per year. Delftland Sand Engine, from reactive to proactive coastal protection. The provinces of North and South Holland on the North Sea coast of the Netherlands are protected by a 120 km long sandy shore, the Holland coast. Before 1990, coastal protection was managed with a hard engineering strategy, dams, reinforcements, and acceptance of beach erosion. After 1990, the policy changed and nowadays the coast is maintained by nourishing it with sand mined offshore. In 2000, after measurements showed a steepening of the lower shore face, 6-8 meters below mean sea level, it was decided to extend the sand nourishment strategy to deeper water. The new maintenance zone, called the Coastal Foundation, extends down to the -20 meter deep contour. Since 2000, the average volume of sand used to nourish the entire Dutch coast has amounted to 12 million m3 per year. Along the Holland coast, an experiment is being carried out with a concentrated mega-nourishment with 20 million m3 of sand, the so-called Delftland Sand Engine. The present coastal maintenance practice of small-scale nourishments is climate-robust for existing beaches and dunes, as it is flexible and adaptable. Mega-nourishments are expected to mitigate some of the negative impacts of small-scale nourishments and create additional wildlife habitats and opportunities for recreation and economic activities. The mega-nourishment experiment is considered a logical next step in the existing coastal maintenance strategy with shore nourishment in the Netherlands. The Delftland Sand Engine was completed in mid-2011. This mega-nourishment was expected to reduce construction costs, create a more natural coastal profile in the long run and provide a number of ecological and recreational benefits. In the long run, the body of sand will be redistributed over the shore face, beach, and dunes, thus enriching the entire coastal cell between Rotterdam and Scheveningen. The environmental impact assessment described the pilot project as follows. A sand engine is a large sand nourishment just off the coast. The sand is distributed by waves, currents, and wind in such a way that the coast continues to grow naturally. This creates a buffer of sand on the coastal foundation against sea level rise, thus guaranteeing the safety of the coast in the longer term. It also creates extra space for nature and recreation. The scale of the sand engine is larger than ever seen before. That is why the construction of the sand engine off the Delftland coast has the character of a pilot, meant to gather knowledge on how to build with nature for climate adaptation. Coastal erosion is a pressing threat, but we can protect our coastlines and ensure a sustainable future with a deeper understanding and effective management strategies. Don't forget to subscribe to our channel for more informative videos on coastal topics. Thank you for watching.